Please run. Hi, everyone. Welcome to Optimizing Exchange Online for Efficiencies and Snappy Experience talk. I'm Prabhjeet Tivana. I'm the lead PM for Exchange Scale and Performance team. And along with me is...
I'm Bob Samer. I'm a PM. I own scalability on Prabhjeet's team.
So just before we go into the talk, a few things, what we are covering in this talk. This talk is divided into 4 sections. We talk about our diagnostic platform. This is the fabric by which we enable efficiencies and snappy experience and capacity management in the service. And then we talk about how we do capacity management, how do we do modeling, how do we make sure that we are able to measure and monitor the capacity which is deployed, and also like what kind of safeguards do we have on capacity. Then we talk about our efficiency pipeline. This is basically will show you like how from the time the dev is coding to the time it is deployed worldwide, how do we measure and make sure that we don't let the regress bits go into production. And finally, we will talk about the user experience, be it our clients like OVA, Outlook and all, and also like our protocols, and how we measure, monitor, and enable great experiences for our customers around the globe. Little bit of disclaimer that this talk is more geared toward Exchange Online service, but the concepts, principles, and the outcomes of these efforts accrue both to the service as well as to the enterprise. So we'll start with our diagnostic platform. How do we measure, monitor, as well as collect different KPIs, metrics around perf and scale all the time from our service? So I'll introduce you to EDS. This is Exchange Diagnostic Service. This is basically the fabric by which we do all our capacity triangulation, experiences, and all those things. It's a real-time diagnostic platform. Our goal always have been to know and learn and measure everything as the users are using our service, so that we can know where we are regressed or where we are not optimally performant. This platform is able to transform any log types. And when I say any log types, it doesn't matter if it is structured or unstructured log, or if it's event logs or IS logs, or all of performance counters which sit on the box. So how it works is, basically there is an agent sitting on every capacity node in our service, be it our front-end CAS roles or back-ends mailboxes or Active Directory. All the roles have this small anti-service sitting on each of the nodes. In this anti-service, one of the things is that we plug in the analyzers. So think of analyzers as something which is able to read and transform logs to extract the KPIs or extract the optics which we want to know about. It can process this, so these analyzers are there for each of the specific logs as well as our performance counter set which we have on each of the boxes. When these analyzer runs, they basically do 2 things. One is they can transform the data, like from IS logs you can find out how many over connections are happening, how many Outlook connections are happening, and those kind of things. And it can also take triggers, like it can trigger a workflow, which can be like, hey, if the CPU exceeds the threshold, go and collect VSTS profile, F1 profile, memory dump, and those things. And it can also do things like it writes to a local event log by which our alerting engines can alert our on-calls to take action. We do push all this aggregated data into our distributed SQL Azure store. We have a highly scaled SQL Azure story around this thing. Just to give brief insight into that, how we keep this data is like we keep high fidelity data, our data aggregated at real time within minutes for almost 30 to 60 days. Then we aggregate it at an hour level and keep it for 3 to 5 months. And then we aggregate it at a day level and keep it forever. All these things are config driven based on how we want to up and down these collections and transforms. We can do that. Going into how we use this platform and what are the capabilities of this platform are. So starting with, we use it extensively for capacity and load triangulation, knowing like, hey, what is the resource utilization across our server farms? how many connections of different types are happening, what kind of error exceptions are happening. The data here is all driven by the user actions. It's what we call as a passive monitoring data instead of like active probes and all. It is integrated with our Watson pipeline. That's basically a reliability engine where we are able to know how many crashes are happening for any given process. And if the crashes are happening, we collect all the right diagnostics, able to find out in almost real time, like what are the issues which are causing those crashes. And then we use this same platform for our end user performance. So we massively collect data around how our experience is by geographies, by our tenants, by our ISPs, data centers. There are many, many pivots by which we try to keep that pulse live in real time to know how we are. And then we can trend all these things and are able to spot outliers, like if specific ISP goes bad, or if a specific data center starts showing some different network characteristics, those kind of things. This is a single repository for all our performance counters. And most of you have used Exchange. We are pretty heavy on number of counters and instances we have. And this is a single repository. Think of it as we have a perfmon in the cloud for all the service machines. Of course, it has a self-service UI. The cloud perfmon is the one which I spoke about. We will show you how we look at our capacity, what kind of optics, heat maps we have there. As I said before, it can store and output any kind of data. It doesn't matter. Logs doesn't need to be transformed from the component teams. The analyzers are able to take care of that. The other thing is it's scaled for millions of users and thousands of servers. So as we add more and more capacity into our data centers, we don't have to touch this piece of our fabric. So if we add 10,000 more machines, the elasticity in which we are able to expand this platform goes along with it. One of the things after that, which Bob will be talking about, is how we do build over build measurements. And as you might have seen from our deployment talk, we are very agile in how we take builds from the dev check-ins to the actual worldwide to our dog food environments and so on. To make one of the core principles or core outcomes of Exchange Diagnostic Service is to reduce the mean time to resolution of issues. So we have enabled a lot of tooling, a lot of optics on top of it, so that when a page comes or when an alert comes to on-call engineer, they are able to see all the different diagnostic aspects of it. Like, say, for instance, we'll show it, but like, for instance, if a CPU threshold is breached, we not only say that, hey, it's 90% or whatever, we also show what are the different processes and stack them, which one is running away. We also automatically collect the associated F1 profile for that, run analysis on top of it in an automated fashion, find where in the call stack we are having problems, and to the extent that we are able to route the bug to the right component team. Just to give you some picture of the scale of EDS, one of the principles when we built this platform was that we don't want this itself to be heavy consumer on our capacity nodes. So the amount of compute which we use per node is less than 2% of a core, not CPU, but a core, and memory is almost negligible. On a daily basis, we collect across our Exchange service 50 billion data points from our logs and our performance counters. This doesn't include what we collect from our active monitoring probes. This is the actual real user KPIs which we collect. That 50 billion is for service health, be it resource utilization, load, capacity, errors, exceptions, all those things. But beside that, we also collect almost 3 to 4 billion of end user experience KPIs to know how we are performing across the world. As I said before, this platform uses our cloud, Azure cloud, to keep our diagnostic data and is able to expand in an elastic fashion. Since we are doing a lot of aggregations at a different tiers, the data size doesn't bloat, so we are able to manage it pretty well. We have over 1,000 Azure DBs. This number keeps changing on a day-to-day basis as our service is growing at a almost infinite rate at this point. And we have over 25 analyzers for different log types, performance counters, event logs, and so on. The last thing, the last thing is on a single box, we collect over 2,000 instances in a real time, and this happens all the time during the day. So this is just a sneak peek into what kind of tooling we have built on top of our reducing the mean time to resolution of our on-call engineers. This basically is showing how the CPU is being used on a given box. We can go back and forth to any point of time, real time. We can select one machines or tons of machines here. We can go at a DAG level, forest level, site level, data center level, and get a quick peek into how the CPU utilization across is. So the 20,000 KPIs which I was talking about, all those 20,000 KPIs and more, we are able to plot it in a real time and able to keep an eye on how the service is performing and how is the capacity and load happening at any given time. So if you go to the next tab, this is basically just to show you like all our hardware is available from here, DAG, site, forest, all those logical groupings and aggregations are there. And one can select it from any time range, date range, and any combination of server roles and be able to see that. Can you show the alert? So this is a sample of like what our on-call engineer will get as an alert. So this is specifically is talking about CPU threshold being breached. So as you can see, it's not just telling you like CPU threshold has been breached, it's also giving the context of how many users, how many tenants, how many machines have been impacted in that logical grouping. And then if you come down here, you can see it gives you what are the top 10 processes, how much is being consumed by each of the process. Clearly LSS is a runway process on this specific example. And if you go down more, you can see that it has already collected the right set of dumps, F1 profiles and all those things, and have been analyzed, and the output of the analysis is available for on-call engineer to use and triangulate the issue which is going, for which this page was done. Okay, go back. Any questions on our diagnostic platform before we move into how we do capacity management framework for our service? Okay. So in this slide, I'll talk about two things, like what is the process by which we do capacity management, and what are the core principles by which we operate our capacity planning in service. So starting with the flow, we start with projections like any other capacity planning exercise, but these projections have two flavors. One flavor, of course, is what comes from our marketing in terms of signals they are getting from market, like how many users of what different service plan type will be onboarding. And then the other thing is we look into organic signals a lot also, like if we know in a specific region, specific country, how the users have started, like for instance, if when a tenant is onboarded to the time when they have n number of mailboxes on service and they start sending Y emails, we try to portray that and then use that as organic signals to find out how much capacity do we need. One of the things which we do all the time is the automated user profiles. So think of user profiles as like by a geo and by a service plan type, we are able to know like how much, what kind of activity users will be doing, like how many mails will they be sending, how many AD objects will they have, how many different folder types will they have. All those is user profile, because this is the pulse of our capacity management. If we lose track of or we get blindsided on how our users are using our service, then it becomes difficult for us to do the capacity management. Once we have user profiles, we also look into compute models. So compute models are the unit of normalization of our capacity management is mail flow. So we track very closely, like when a mail flow operation happens, how much CPU cycles are being consumed, how much memory working sets are being consumed, how much disk I/O is being produced. We keep over build rhythm on that, and we try to either keep a steady line on these compute models or try to optimize them all the time so that the cogs keep on decreasing and efficiencies keeps on improving. Once we have these three things, the projections, the user profiles, and the compute models, at that time we can go ahead and find out very easily in our mathematical models like how much CPU we need, how many disks we need, how much I/O capacity we need. So all these things can lay over pretty well. And then we map them to the different SKU types which we have or which we intend to procure. And once we have that, then it goes through the regular cadence of procurement and automated deployments. But then the main thing here is, irrespective of how much input of capacity is coming, we keep a very close eye on how it is being utilized at any given time. So this whole cycle basically is a continuous iterative process which we run all the time to keep a pulse on, are we using our capacity in a right manner or not. Few of the high-level principles which we use for capacity management is, of course, like any other cloud provider or any other data center operation, we try to run the hardware to full efficiency. Logical models and usage patterns, this is where we are doing a lot of machine learning kind of activities on our EDS data to accurately predict how users are using our service. As I said before, cost per mail flow is the unit of capacity management. This is how we are able to know like how much capacity we need today and how much capacity will we need in 6 months. The other thing which we do is CPU utilization from interactive workloads. In non-failover scenario, when we don't have any single site or double site kind of a failovers, we try to keep it at 50%, and in failover scenarios, we take it to 80, a little over 80% to allow site failovers. So this model basically gives us a kind of a buffer in our hardware capacity so that we don't have to juggle the moment the site failovers happen. It's built into our capacity modeling to do that. Like any other cloud service, we bank heavily on commodity hardware. Like everyone else, our strategy is to scale out and not scale up. We do focus a lot on real-time capacity usage and user performance and scale. And as I said, the study line which we want to keep is around our compute models. So we align our software scale and performance optimizations to go with the compute models which we have in target. This is a sample capacity model which we use for our service. As I was showing before, we come up with a sample forecast. This is a combination again of our organic as well as market projections. And then we come up with the user profiles. This is sample of like a different type of service plans, how many mail flows they do, what kind of activity rate do we see for those service plans, what is the size of mailbox, how many number of mailboxes are there per tenant, how many AD objects they are, how many folders they are, and so on. And along when we are doing our user profiles, we also do our compute model. So this is like, hey, when you're doing a single mail flow, how much cycles are you or how many disk IOs are you doing per server type, be it mailbox, CAS, or Active Directory. These user profiles are built and iterated and plugged into our capacity model on a monthly basis. But these compute models are basically almost on a daily basis because we are churning out new bits on the daily basis. And once we have these three things put together, then we put together basically a model which says that by quarter, by fiscal year, and so on, how many different kind of server roles do we need? Do we need 200 more DAGs, or do we need 1,000 more CAS boxes, those kind of things? And then it is overlaid with our budgeting and all those things into know both the aspects, the CapEx and the OpEx for these. So once we have deployed capacity, how do we make sure, because in cloud services, as we all know, there are always deviations, there are always outliers, there are always hotspots which happen, be it a day after Thanksgiving or a day after any other holiday in a specific country. So we do 4 things when to make sure that we have safeguards, enough safeguards in our service that capacity doesn't melt. The first thing which we do is of course the one which I was saying, the real-time insights into resource utilization, load, and experiences. This is the key for us to be able to maintain our capacity rhythm. And we have threshold breaches. Threshold breaches are not just, hey, we exceeded a threshold, but it's all about automated workflows to understand what happened and why happened, where in the code did we regress, or something happened in the network or data center layer. The capacity triggers is the next one, the one which I was showing you before. That was one example of a capacity trigger when CPU threshold was breached. So that we have these capacity triggers for all things like CPU, disk, memory, experience, and our on-calls get all those, and the engineering gets a rhythm of those. The third safeguard we have is around workload management. This is our investment or a framework to throttle and to shave off the peaks and fill the valleys. So interactive workloads get resources during peak hours, like mail flow and all are always the highest priority workloads, but things like assistants and all, they utilize the boxes at the non-peak hours, and how that is managed is through this workload management engine. It also helps us in safeguarding and preventing DOS attacks by a rogue user or a new device which comes and starts pings and syncs with the service at a very infinite rate. So throttling as well as shaving off the peaks and filling the valleys is taken care by this workload management engine which we have. The fourth one is the process isolation. As you see in Exchange 2013, we have a large number of processes running on a single server role, especially a mailbox role. So how do we ensure that one process doesn't eat up all the resources on a box or a DAG and so on? So this framework basically establishes the caps as well as how much a single process can consume in terms of hardware resources on the box. This has been very, very helpful from us to cap like runaway processes, and it does a lot of self-healing actions based on that. Like, of course, there are things like we collect workflows like VSTS profiles and all when the process runs away, but it also gives a cap so that other processes are not starving because of this single process going nuts. I want to show the real-time heat map. Yeah. This is actually a live display of how a capacity is being utilized right now in our service. So you can see, of course, there are different aspects or different pivots or aggregations for this thing, but this specific aggregation is showing how are we doing in terms of CPU on cafe, mailbox, directory, how many DBs are there in that specific site, how much is the queues, how many connections are happening at the front ends, how many, and most important, how many machines are in rotation at that given time, and how are the databases distributed among those machines. And the last column basically shows like, hey, is the migration activity happening in this specific site or forest at this point or not? So we can, and then it goes back and ties to the workload management and all those things which we have. The other thing which we keep very close eye on is what we call time to die. So for each of our logical aggregation of server roles, we keep an eye on like how much room do we have based on our organic signals, based on the growth of a specific tenant usage or specific forest or site usage. So this specific example goes over how much time do we have in each of these forests in terms of when we will run out of disk space on that. We keep a very automated and a very close cadence on these things to see how much is space used right now, how much is available, what is the incoming rate of the data for that, what is the monthly growth rate for that specific forest, and most important, like how many months or weeks worth of capacity is available in that specific logical unit, so that our procurement and our capacity modeling and all those activities can stay in sync. We aim to maintain sufficient buffer to handle emergencies, and we have a similar kind of time to die optics for other things like compute and I/O. Yeah. So with this, I'll give to Bob to talk about our efficiency pipeline.
All right. Hello, everybody. Thanks, Project. Okay, so I'm going to talk about efficiency pipelines. Everybody's excited, right? Woo, efficiency pipeline. Wake up. Okay. So when Bob first asked me to talk about this, I thought, I own the scalability pipeline, and so the fact that it was renamed I thought was interesting. I'm assuming that it's an optimization we're making. We're saving one letter with efficiency versus scalability. So I'm assuming we're doing titles now. That's where that's coming from. So let me give you a little context about the pipeline and the kind of work we're doing, and then I'll talk in detail about how it works. So at the end of the day, this pipeline or this process that we go through is to keep track of the resources that we're consuming as builds, as this rapid change goes out to production. Resources, by resources I mean CPU, I mean memory, I mean disk. The reason that it's important is that we are running at such a high scale in Exchange that a small regression in an important area can be magnified and actually cause lots of problems in production, like actual service alerts, like we showed you one of those EDS alerts, or capacity shortfalls where we're unable to, we don't have enough buffer, we have to steal from our buffer to meet the needs to serve the or historically, the way services did this analysis is they would build a lab and they would try and get that lab as close to production hardware, and then they would write a bunch of automation to simulate a bunch of users and a bunch of mailboxes for Exchange, and then try and go through this iterative process where they would run a test that takes 4 to 8 to 10 hours, see what happened, see if there's bugs in there, work with the development team to get the bugs fixed, lather, rinse, repeat kind of process. And that worked relatively well in the past. With Exchange, with just the sheer scale that we're at in terms of users and requests per second and just activity, as well as if you went to the deployment talk, you might have seen how quickly we're shipping. We're shipping on order, 4 builds a month, thousands of changes a month are coming into the pipeline. There's no way that we can build a lab big enough or evaluate results fast enough to use that historical model. And so the way that we approach that is the efficiency pipeline. So let's see. Okay, so the efficiency pipeline, it's a set of stages. It's a set of stages that changes move through as they go into builds, and then builds are validated as they go into releases. There's 4 main stages. I don't remember let's see. So there's a dev stage, and then there's kind of this dog food slice in production. An important, difference between these two is that this is all done on essentially for the most part, on the dev's desktop. So we try and catch egregious issues, things that we know are going to cause really big problems in production before they even get into the build. And then these areas, these latter stages, are actually done. The evaluation is done using real user production load. We don't simulate anything. We set up this set of gates that we have to go through where we actually have the real user production that we're evaluating. So it allows us to allows us to trust the data much more, and actually allows us to set up these gates. So let me talk a little bit about the first stage, the dev stage. So we do 3 things in this stage, essentially. There's a set of static analyzers that essentially are, when the dev is writing code and he or she goes to check in or goes to build, there's an evaluation of looking for patterns that are known scalability killers or resource hogs. So like you allocated but you didn't free, or this particular construct leads to really bad contention. Things that we know we've been burned by before, we tend to get them into the static analyzer, so we catch them before they even get in the build. There's another set of tests that are run as part of the check-in process. That's this idea of metric accounting tests. So there's a set of metrics that are super important for Exchange, like RPCs, number of AD calls, that kind of stuff, that we never want to see go up. Like if they go up by 1, it's going to be this huge magnified effect when it gets out to production. And so we have this set of metric accounting tests that's looking for just +1 increases in some of these core metrics. And in that situation, we won't let the dev check in either. They'll have to come and fix it or try and convince us that why they think that they can have a 20% increase in AD calls. So that's this first phase, or that's the first part of this stage. Generally, that covered, like most changes just go through that and then go over into this stage. And I'm going to spend a little time on this. It is infeasible for us to build a lab and simulate the entire Exchange system before we go into production. But there are some core components that do component load tests, if you will. So there's a little bit of lab still in the system. So an example is our storage layer. There's not enough. What we found is that there's not enough static analysis and metric count. The safeties that we get with the static analysis and metric accounting tests for store weren't quite what we needed. And so there's some level of component level simulation that happens kind of in parallel with the rest of this stuff. And if a bad issue is found in there, then it'll stop. They'll come back to us further down the pipeline. So far that has actually not happened, but it's a good safety that we have. But again, they're not trying to simulate the whole set of Exchange. It's literally just, here's the store APIs, input, outputs. Can we get to a smaller set of scale goals? And then maybe the more interesting piece for you guys is, or for on-prem folks, is that we also use these per component simulations to validate some of the on-prem before a CU goes out. In addition to all the service stuff we're doing, the fact that we use the same code for the service, we do some per component evaluations as well, and those have to pass before we ship a CU. Okay, so that's the dev part of the pipeline. And as I said, once you move from here to here, you stop doing single machines and artificial or simulated tests, and we're using real users here. So dog food also, it's also called service dog food or SDF, if you might have seen that in other presentations. That is a production cluster that the entire product team and a bunch of other people at Microsoft literally have their mailboxes running on. So it's called eating our own dog food. But we are on the bleeding edge of these releases as they go to dog food. So and as part of on a daily basis, we evaluate dog food for resource consumption essentially, and we do that with three tools. First of all, actually I have them in the wrong order, but so let me talk about this one. Because it's a production cluster that that SDF is running on, but there's not that many users. There are some users, they're Microsoft users, but there's not a lot. We actually have to use a tool called automated artificial scaling, which is essentially it leverages just the built-in Exchange stuff to move mailboxes around to do kind of a Tetris style. Let's maximize the mail flow on a smaller subset of machines so we get to a consistent level to measure. We use that to kind of get to production levels on a smaller scope within SDF. Then we generate something called the efficiency scorecard, and I have another slide that talks in more detail on this. But the efficiency scorecard is essentially using EDS that Project was talking about to pull the aggregate for the daily peak of this environment, how much CPU, how much memory is every process on every box in what we're measuring, how much is it using essentially. And we take that, we use artificial scaling to get there, and then we have the capacity model that Project also talked about. And we have, within this thing called an efficiency fuse, we compare the actuals versus the model, and we have a threshold that's appropriate for the phase we're in. If it crosses the threshold, it's pretty simple. It blows the fuse, and it works just, it's theoretically the same kind of way, or not theoretically. I can't think of the right word for it, but it works similar to how an electrical fuse would work. If the current's too high, the fuse trips until you unplug some stuff or you go figure out what's going on, and you flip the fuse back on and continue. So in this case, if let's say store, since I'm picking on them, was over its threshold in SDF, the fuse would blow, the store team gets notified, they get forensics data as part of that says, here's the CPU that, you blew the fuse, here's the processes that blew the fuse, here's the CPU and the other information you need to help solve the problem. They go, at that point, it's a decision where we decide if we can live with that level or we go and patch it. Usually we get it patched. They get the patch back in and we move on. The good thing about the forensics data that we give is that it helps. What we found for a long time was, when we tell other component teams within Exchange that they have a bug, they have a scale bug, and they have to fix it, they go through the kind of 4 stages of denial, or 4 stages of grief. What is it? Denial, depression. What is the other one? Anger and acceptance. That's right. And so before we were giving them this extra data that said, okay, here's no, really, it's you. Like, it's your team, it's your component, it was your change. Until we started getting the forensics data in there, it just became oh well, we don't believe your data, or we don't, or are you sure that's that bad? Are you sure your threshold's right? Once we had all of it, this is real user load, real forensics data, it became it's much more efficient process. So that's SDF. Another thing that we do within SDF, actually within all these phases, is that most of the efficiency stuff is around how much resources we're consuming, so CPU and memory. But there's also a kind of another side of efficiency, which is reliability. Like, if you're not reliable, you have really bad efficiency as well. And so we also monitor the number and rate of crash reports. So like Watson's, essential Watson, the stuff that gets submitted to the Watson pipeline. Okay, so those are the activities that happen in this phase. Assuming that the fuse hasn't tripped, we go to the next phase, which is a slice in production. As I said, dog food SDF is one production cluster with enough but a small number of users. So it tells us something. It tells us more than what we knew in the dev part of the phase, or the dev phase of the pipeline. Slice in production is where we really kind of get into it, in that that's a number of capacity units and a number of users across those capacity units. Similar mechanisms happen as in SDF. We still use artificial scaling, because even though it's more, we pick from more capacity forests DAGs and capacity units, but there's still not, in any one, there's still not a huge amount of users. There's a larger amount of users than dog food. So we use our artificial scaling to scale up each one of those. We do an evaluation with the scorecard across all of them. There's a fuse, again, that has to not trip to go to the next phase. Let's see. Okay, so yeah, so that's slice in production. Again, we do the number and rate of crash reports. And as we go through these phases, we tighten down as we get more machines and more users, we tighten down our thresholds, so that because we can be more accurate as we get more machines and more activity. And then the final stage, assuming that goes well, we go on to the production stage, which is more kind of a fan out to all of production. So instead of going from, after that, instead of going from stage to stage, we do more of a percentage upgrade of everything. And so in that stage of the pipeline, we don't necessarily have to use artificial scaling. Every once in a while we do, but for the most part we don't need to use it, because we've got enough users and a high enough mail flow. And so, but we still have fuses that are there. We still generate the scorecard on a daily basis. We still have a fuse that can fire if we cross the threshold for production. But essentially, once you get over here, at the end of deployment, then that build or that release is out to production. It's on every machine in production. And so we're trying to stop, we're trying to stop regressions from getting into the pipeline this way. Once we're here, we do an additional point where we use the efficiency scorecard, and then we use other runtime metrics like mail flow for an individual capacity unit, or number of requests for a set of front ends. And we create essentially a heat map or a utilization report that says, okay, this is how busy everything, this is how things are balanced, and I'll show a slide that has that. All right, I think I covered that. Okay, so efficiency pulse. So this is a sample of our scorecard. This is the chart that gets shown. There's also a numerical breakdown that I thought would be hard to read. So essentially, the efficiency scorecard, all it does is for peak hour of every day, go and pull data from the EDS platform that's already being stored. We do a breakdown per process, so per process and per groups of processes, essentially. And then we normalize by a metric that's appropriate to that role, so that we're able to compare between processes, between process groups, and also between builds and machines. And so, for example, for mailbox, we use requests per second. For front end CAS servers, for mailbox, we use mails per second, so mails delivered per second. For front ends, we use requests per second. This chart on the right is actually the trend over time, over builds of our production mailbox stuff. So how many cores per message we're using, and so this is our model, and you can see we were over our model, and we were slowly getting under our model over time. And then you can see the breakdowns, right, each kind of group of processes. So there's the store process, which is the most, and then the search process, and then I have ES here. Like I said, we track it daily. It's across that's an important point. This scorecard is generated for every scope in production across every data center. So every capacity unit we have a scorecard for, and then also the aggregate. So, for North America, we get a scorecard for the different containers we can aggregate up and get an evaluation essentially. Gives you deep insight into every process that's running on the rolls. And then, as I showed you in the pipeline, this is the input into the fuse and the thresholds within the fuse that basically stop progressions from going further and hold us to our capacity model. Okay, so next one. Okay, so this is a version of the reliability. So this is the reliability scorecard, if you will. Essentially, we're a similar concept to the efficiency one. It tracks daily, weekly, daily crashes essentially, and so you can see. Oops, sorry. You can see over here the number within the last 7 days, number with 14 days, 21 days, 30 days, per groups of processes again. Again, leverages the EDS platform. It is tightly integrated with the Windows Watson pipeline. So essentially when any of our machines will upload data to the Windows Watson pipeline, that upload contains a cab file that has interesting forensics data and call stack information. And then within the website for Watson, we're able to go and investigate, like, how many times has this crash happened, and what does the actual call stack look like? And it allows us to kind of get on top of those things and fix them as we're going through the phases of the pipeline. Okay, this is my second to last slide, I think. Okay, so capacity utilization. This is I mentioned this at the end of the efficiency pipeline, but this is essentially using that scorecard that we generate for every scope or for every capacity unit, plus the current rate essentially of the thing of the most important metric for that role. We use this to figure out danger zones essentially, or risk areas. And so you can see this appears our CAS role. This is a mailbox role, and this is an example of just a subset of production. This isn't our entire production, and these numbers are somewhat made up. So, but essentially, anything that's above in the red zone means that's approaching trouble, and so we work with our capacity team to balance traffic out. In the case of CAS, we do load balancer stuff to balance traffic out so that they're under the red zone. In the case of mailbox, we actually have two regions because we can do single and double site failovers. And so you can see that generally we're doing all right. This is the mail flow, that as long as the mail flow is low enough, we're not in trouble. But there's this one set of capacity units here that are in the yellow in the red zone, and we had to work. That was a deal where we had to go work with the capacity team and the load balancing team to kind of pull from some of our buffer to get more capacity and then load balance across, and to shift that down essentially. Interestingly, that wasn't due to a regression coming through the pipeline. It was actually due to an onboarding mistake that we made. Let's see. I think I got that covered. All right. So I've got three examples just to kind of talk about how we've used the pipeline. So there's one example is SMTP. So SMTP is, we've got one of those metric accounting tests that I mentioned that counts the number of AD calls that SMTP send makes. And it actually literally went up by one. The dev that wanted to check it in got stopped. Like the test ran, caught it. The dev worked with us, and we did the analysis of like, okay, well, this one extra AD call, if it went all the way out to production, if you think about every CAS server and every mailbox server is making AD calls, so they're all doing 20%. I think it was about a 20% increase. I can't remember exactly what the number is. 20% increase that was going to happen. We just couldn't afford having that happen. So what was great about that, the SMTP one, is that it never even made it into the build. It stopped it at the dev's desktop essentially. There was an interesting one that was OA. This was an OA regression that came into dog food that we picked up in SDF. It was actually a 3,000% regression, so it would have killed us if it had gotten further. But there was one that we actually tripped with the efficiency pipeline, tripped the fuse, everything worked out. It was one of our first ones that we caught with the pipeline. It looped in the OA team. The OA team looked at it. There was a little bit of the denial, a little bit of the phases, but they quickly went through those with the data and were able to make the fix. And we got a persisted patch that was applied, and then we were able to continue deployment with a pretty minimal delay. And then the last one, this one was an SDF. As I said, it was a giant. It was like 3,000%. It was a huge regression. This one right here was actually a much smaller regression. It was more, I think it was a 50% regression. So this one we couldn't catch in SDF. It wasn't big enough. There's not enough a big user population there to catch it. And so we didn't catch this one until SIP. But once we got to SIP and we had scaled up, this popped up, and same thing. We quickly jumped on it. The EAS team looked at it, issued a fix. They had made a bunch of changes there that actually were, it was a kind of a big rewrite that ended up with a regression here, and we were able to stop it in SIP. So the pipeline, the strategy has been working pretty well. We haven't had a ton of issues get all the way through to production. I think that's it. That's it. Any questions? No? Okay.
Thanks, Bob. So we talked about the diagnostic platform, how do we do capacity management and service, and what is our pipeline which enables these efficiencies and optimal capacity utilization from dev box to production. But all that doesn't matter if we are unable to give great experiences to our end users in terms of how the different scenarios behave for them or how the page load times work for them. So in this last section, we will be talking about what do we do to enable great end user performance for our customers worldwide, be it OVA, be it protocols, be it MOVA, or be it our thick clients like Outlook. So like as capacity as well as scale pipeline, we try to keep a lot of pulse on what's happening. To make it simpler, we can divide all the investments which we do in this space into 3 sections. The first one is the development cycle. Like how do we make sure that when we are coding, we are adhering to the best practices, we are writing a code which can actually be light, snappier, and work performant for our end users. The second one is the dog food and production. This is where we keep a very high pulse. I'll show you like what kind of metrics and what kind of data do we collect and how do we use that to optimize our end user experiences. But here we keep a lot of eye on what's actually happening in the production data centers of ours. And of course, this pillar doesn't become full if we don't have a customer insight into like what is actually happening to our end customers, how are tenants experiencing the different clients which they use. So in each of these things, there are specific focus areas which we are looking at. So if you look at the development cycle, we look a lot at how do we design for snappy experience? How does our next rev of OVA or current rev of OVA or MOVA or outlooks or protocols can be enhanced so that it adheres to the actual realities of the network of the world, the actual realities of the latencies and bandwidths which we see around the world. Of course, in US, we see great bandwidths and latencies are low, but when we go to the countries like India, China, and especially in Latin and Africa, the game changes pretty quickly. So so during the design phase, we keep a lot of focus on having the best experience analyzers and those kind of things run on our dev codes all the time. The things which we optimize during the development cycle are bytes over wire. We want to keep them as low as possible because this is more important for countries which have low bandwidth, high latency. Number of round trips, we try to keep the number of round trips coming back to our service to minimal. We do scenario performance. We look into how is, like, say, in Outlook case, how is the performance when you sync your client, or in OVA, how do you inbox page load happens or calendaring happens. So we do a lot of measurements around that and a lot of code automation and code checking around that in our design phase. Once we go into dog food and production, we keep a very strong pulse on how are we doing across different ISPs of the world, different geographies of the world, how the experience varies between, say, Canada and China, and what are the reasons why those experiences differ, and what can we do to optimize those experiences. Same thing, scenario performance. We continue to have a deep pulse on how different scenarios are happening in the real world. The other thing, especially for our web clients, the page load ratios matter a lot. The PLT one being the page load without any cache, like browser cache or app cache in play, and PLT2 being with some the app cache and the browser cache in place. So we try to keep these ratios, we watch these ratios very, very religiously and on an almost daily basis too, because our goal is, and at least our aspiration is, that we want to give more and more PLT2 kind of experiences, because that's when our users get the most snappier experience. We do keep a pulse on like what kind of browsers and device types are being used across the globe, like what kind of mobile devices, as well as the distribution between Chrome's, Firefox, IE, and all those. And in the final one, on the customer side, we have a lot of focus on tenants themselves. Like, say for instance, in a given state, like say take a Washington, we absolutely know like what are the different percentile of experiences for different users in state of Washington. And if a specific tenant is getting an experience which is say in 50th percentile or 60th percentile or lower than that, we consider that as an outlier. And then we do a deep troubleshooting to figure out like why that specific tenant is having an outlier experience. We do focus a lot on tenant routing. This is how they get routed to our data centers around the world, especially how close or how far the proximity by when they enter our network and where their mailboxes are located. Like in our platform, in our production and dog food environment, we also very closely watch tenant experiences by different geographies, different ISPs, different networks, and so on. We try to keep a very good map of like what are the different latencies and bandwidths by which people are using our experiences, be it our clients or be it our protocols. And then we have, I'll be showing it a little later, but we have tenant troubleshooting tools which we have built. All these end user performance optics which we get, they give us very good patterns. They give us a lot of data, but to go a little more deep, we have tooling available for our tenants which they can run to identify the precise root cause of the failure or the bad experience. So how do we do this thing? So from instrumentation perspective, of course, there are three flavors here. We have web clients and mobile clients like OVA and MOVA. We have clients like Outlook. And of course, we have protocols like EAS and EWS and so on. OVA and MOVA are fully instrumented with our JavaScript POF markers so that we don't only know the actual latencies or actual experiences, but also the perceived latencies and perceived experiences. We are highly coupled with modern browsers, W3C navigation and timing APIs. This is one of our core source by which we are able to capture from the browser what kind of experience users are getting around the world. In Outlook, same thing, we have instrumented and the payload comes back, instrumented the client for the scenarios and the payload comes back to our server. And then it goes through the EDS pipeline for us to be able to know how our Outlook experiences around the world. And same thing with the protocols. On protocols, we focus a lot on like what is the experience on the wire, like how is the EA, ActiveSync, and EWS, those protocols are having experience on the wire as well as on the server side, like once they reach our server, how much processing, how much latencies, all those things are involved. From tooling perspective, the three strategies which we use is, of course, first one we have always on synthetic scenario tests from the last mile and the mid mile. These are deployed all over the globe. The good thing about these synthetic tests is they just don't give us the scenario experiences by geo and so on. They also are able to capture certain traces, certain type of traces which we care for, and we are able to look into that and figure out like what is happening in a specific geo or specific ISP and so on. These are running all the time around the world. And then the real-time monitoring of user experience. This is the EDS platform which we talked about earlier, where we collect for every single interaction with our service and then pivot it by different metrics like DC, Geo, ISP, and so on. And finally, the third aspect of this triangulation is the customer tooling which we provide to customers, which they can run standalone, they can schedule it, and basically the goal is to empower the customers themselves so that they can find out what's wrong and what needs to be fixed to identify the root cause of failure. We have a core focus here that we are able to measure every millisecond of user experience. So if someone is getting a 3-second experience somewhere, we want to know how that 3-second stack looks like, how many milliseconds are being spent in network, how many milliseconds are being spent in DNS resolution or CDN downloads or just getting to our data centers, those kind of things. Again, to recap, the focus of our experience is every single geography. We measure, monitor in near real time all 230 markets we are in. As I was saying, we collect on end user performance itself more than 4 billion data points every day, and that doesn't include the 50 billion which we collect on the service side. We monitor every single ISP. We know the performance of our service by 22,000 ISPs which our users use around the globe. We know every single tenant, and number of tenants here is hundreds and thousands. We know exactly, even if it's a 5 mailbox tenant to 100,000 mailbox tenant, we know like what kind of experience they are getting. We are able to know like tenant who are multinationals, like what is their experience by country. Tenant A in US and same tenant in Japan, we are able to compare and figure out like what's the reason why they're getting a different experience. And of course, every data center, this is to optimize provisioning and all those things. Like a single tenant can potentially be in multiple data centers, but how do we know which data center is the tenant going to get the most optimal experience? And as Bob was talking about build over build rhythm on figuring out like how much resource utilization is happening, we also have a same rhythm for experience where we measure build over build, same things by geo, by ISPs and so on. And if any of the regressions happen, the same fuse concept is applied there, and we don't let the build go if, like for instance, if the bytes of our wires increase or the number of round trips to our service increase. You want to go to the real one? So we'll show you a few of the optics. So in this is actually a real map where we can see, we can zoom in and zoom out to different countries. It covers all 230 countries. We are able to see, this is an example of our inbox page loading, like how in different countries people are experiencing over inbox load. So if you click on, say, US, we are able to see how is the trend looking for the US. Like, as you can see from the first chart, we can show that it has been pretty steady state. We do focus a lot on like where the users are connecting to our data centers. So in this case, in US, you can see pretty much all our mailboxes for our US users as well as where they connect to our service is within the US. These numbers might vary from other countries. Like if you go to Indonesia, Vietnam or something, these numbers will vary. But we do track this thing very closely, like how much traffic is being routed and are we getting you to the network in the most optimal manner or not. Then this is by data center. So if you scroll a little up. So we can see that in different data centers what is the percentage of our load. And so if you see, these are the data centers where we have most of our load, and what is the different experience we get in different data centers. So clearly, if a US user is in Sao Paulo, this is LATAM, his experience will definitely vary compared to if the user is in any of our US data centers. The other thing which we do is for every single ISP, we measure and monitor, like what is the distribution of the traffic which is coming from each of the ISP. And then we are able to see which ISP is giving us what kind of an experience. Clearly, in this case, you can see Quest is little slower for us in US compared to other. Same things we do for mobile networks, like comparing T-Mobile's, Verizon, AT&T's of the world and seeing where. And behind the scene, then we do focus a lot on peering with these networks, these ISPs, so that we can give a most optimal experience to our customers. So before we move on from this thing, this is showing a weekly, but sure.
Just out of curiosity, China came up as a red. I'm wondering what would show up there.
Yeah.
What's going on?
So China, the countries like China and India, as I was alluding before, there are a couple of things which are happening. If we even keep the Great Firewall of China on the side, which adds to the latency, but the latency of the network within the country is high, and bandwidth of the users which are using are lower. But the reason you see it is red is because internally we want to optimize our ecosystem so that they get the same experience which users in US get. So from our perspective, it is red, but for the perspective of users in China, this is kind of like other services might be a little more slower than them for this thing. But we compare everything with the gold standard on this thing. And China has, if you go to China, I can show you all the different countries after the talk, but if you go to China, you will see that the ISP differences are huge in China. There are ISPs which are like really, really bad, and there are ISPs which are relatively optimal. If you go back to next slide. Next slide. Oh, sorry. This is our experience optics on ISPs. This is kind of things we do. So this is kind of giving you from India. So Tatacom is one of big ISPs in India. We have been working with Tatacoms for almost 3-4 months now. We have put our own pop points within the Tatacom network. So if you see, it is going down as our capacity within the Tatacom ISP increases. So we do monitor like what kind of load we are getting from each sample, but also like how are we trending for each of the ISPs. I have an example like last year, some 12-14 months back, we suddenly in our system we saw that Spain, a specific provider in Spain and one of the biggest ISPs in Spain, has suddenly regressed by more than 60%. And when we looked into the network route for that specific ISP from our signals, we were able to find that that specific ISP has started routing our traffic via US to our European data centers. So we engaged the ISP in a almost urgency base, and we were able to fix and prevent the regression from 60%. That's why, since network is the piece which is highly federated, highly distributed among different properties or different businesses around the world, this is very, very core for us to know how we are performing around the world. Our network organization in Microsoft, the Global Network Services, they continuously work with different networks around the globe, especially in countries like China, India, LATAM, Africa, where network is more prone to different experiences during the day and during the weeks. I've already told about the Spain one, but if you see for ISPs, it's not just about, hey, how much is the page load time taking for us. We collect all the things like if you do a DNS resolution with that ISP, how much time it takes. If you do a TCP connect with that ISP, how much time does it take. If you have to download some byte from the ISP, how much time did it take. So behind the scene, there are like hundreds and thousands of metric for each ISP, each CDN, each tenant, each CDN, and so on. So that was like what we do on the service side in terms of how do we measure, monitor, and how do we optimize our experience around the globe. This is something which you all can do from your desktops, your office, or your home. So we have a version of this tool called Exchange Client Performance Analyzer available today also. But what we are doing right now with an intent to launch pretty soon is to enable customers themselves to look into what is causing the bad experience for them. So we have a tool, this is an extensible tool, which basically collects network diagnostics from end user machines to measure and troubleshoot slow user experience to our data centers. This is the strength of this tool comes because it is highly integrated with our EDS pipeline, because we already, if you run it from your machine at your home, and we are able to know like what kind of latency and bandwidth you are getting. We have billions of data points on our side to say, if latency is 500 millisecond and bandwidth is X Mbps, we know, and distance from our data center is Y, we know exactly what kind of user experience we will be getting. So basic intent of this tool is we don't need to simulate the actual OVA experience or Outlook experience or all those things, but we basically collect a simple network profiles from your machine and are able to articulate where the failure zone is. We don't collect any PII, personally identifiable information via this tool. The failure zone reports are, I'll show you the sample report which we output from this tool, which shows basically what is the cause of slow experience and what can a customer do in that case of. We have lots and lots of examples of where people use slow DNS network providers, or there are instances where there are big corporations, they are connecting to a different country when they're going out of their network, like Microsoft India coming to Microsoft US first, and so on. The tool auto version checks, so you don't never have to worry about do I have the latest and greatest tool or not. The focus area in network especially is DNS. We have seen a lot of difference in the DNS service providers around the globe, and this number can vary from 5 millisecond to 500, 600 millisecond just to do a simple DNS check. Same thing when this tool also does, like what specifically is going with your ISP, what you are using. How is your network being, how is your traffic being routed to our data centers? What is the quality of network from your home or your office to our data centers? How many packet losses you are having, and so on. We look into like what kind of hardware profiles, especially around what kind of device types and what kind of browser versions you are doing. Browser versions do matter when it comes to end user experience. All the modern browsers, i10 and above, they give a lot of snappier experience compared to our legacy because they have app cache and all those goodness and the acceleration protocols built into the browser itself. We look into if you are going to the right cache location, are you connecting to our network closer or are you connecting to something which is far away? We look into if your mailbox is located in a right data center or not. And then using our ERM pipeline, we are able to do predictive analysis, which is high confidence predictive analysis to the confidence rate of 99%, and we are able to say, okay, what kind of page load experience are you getting for different scenarios? So this is, the report is way bigger, but this is kind of report which you get when you run this tool. Of course, we do like, is your basic connectivity to our data centers is working or not? We look into what DNS provider you are using. And in this case, just for a dummy example, we have like this DNS provider is bad. It can be for any reason, people using third-party DNS providers or the ISP DNS providers doing some crazy stuff. But in that case, this is something which we recommend our customers to look into their DNS resolution times and make sure that they are optimal to be used for not only for our service, but for any service. We look into network. We closely look, how many hops did you take before you entered our network? And once you were in our network, were you efficiently routed or not? Things like packet losses, download bandwidth. Bandwidth is important. We have seen bandwidth differences which are amazing. In some part of the world, we still see like 56K modem kind of bandwidths, and then there are part of the world where it's crazy fast. Like in our side of the world, it's pretty fast. We look into what ISP you are using, and what is it good, bad. We do recommend in certain things in these cases. And we do look into environments, like what kind of hardware environment you are. These are just FYI. But the main thing is you can schedule this tool to run behind the scene in a silent mode, and you yourself can keep a pulse of, like if someone calls you and say that majority of your users are having an optimal experience, but say 10 users in different country or different geo are having a problem, this is a good way to run this tool, a very lightweight tool which gives you an output of what's wrong, and you can act upon that.
Does it email the output? Is that if we had this tool kind of at a probe in different locations, how do we get the output? Is it emailed to
That's a good question. So that is something which we want to do, like ability to give customer, like a tenant admin can get, say if 50 people in your organization is running this tool. Right now, the way the tool is in its phase 1 is that specific user who is running it will be able to see it. But we are working on aggregating this data so that tenant admins can go and see across 1,000 users, 5,000 users, whatever. That's something which is something we have in plans.
Are you going to talk more about the tool, or?
If you have questions, I can answer it.
Yeah. Is it available today?
Basic version of it is, if you see me offline, I'll show you. And but within a couple of months, we plan to put a proper support article and all those things on this so that the wider community has it available. So in the end, I would like to talk about a few of the best practices which we all should be doing to get the most optimal experience from our clients around the globe. On Outlook side, we highly recommend to use Outlook in cached mode. The most important, keep your Outlook as well as your operating system with the latest patches. We have, especially on the Outlook patches, we have seen a lot of differences. So please do keep your environment up and running with the latest patches. Bypass proxy for RPC HTTP traffic for Outlook. In our experience, we haven't seen it adds any value. We have seen people doing it. And of course, there are instances because of this, proxies get overloaded, there are packet losses, and then we run into that Outlook connect disconnect issue, which we see many times.
Microsoft IT used to do that.
Yeah, point in case. Same thing for customer with heavy calendar sharing usage. Set permission for non-owner to an owner's calendar to FreeBusy. Calendaring is very interesting part when you are especially when you have employees which distribute across different geos. If you want to do calendaring, these things are important. The final one on WAN accelerators, we have seen a lot of customers use it in their enterprise. Our stance on this is neutral. We don't recommend you. But if you see there is something adding value to it, you can use it. But when you are using a support case with us, we highly recommend that you have an abilities to bypass these WAN accelerators so that we can troubleshoot what exactly is the performance issue on your site. And OVA, again, please, the modern OVA has cache mode. Please use it. We highly recommend you to use modern browsers, IE 10 and latest Chrome, because of the app cache and the browser caching abilities, and especially the protocols which are able to accelerate the experience. We highly, highly recommend that to you. And we also recommend, especially in countries where there are high latencies and low bandwidths, aim for more and more PLT2 experience. Please don't clean out the caches too quickly over there. If you keep the browser cache enabled, you will get PLT2 experience.
PLT2 doesn't make sense to me.
Oh, sorry. So PLT1 is basically what we say page load time without any cache in place. So first time you come to a site, or any site, this is the first time because you have to download certain static content, certain scripts, and those. PLT2 is a scenario where that cache already exists. So the only thing you have to do is the dynamic content which has to come from our servers. That significantly reduces the time to download. We are almost out of time. So in summary, our goal is we want to delight our end users and customers throughout the world with reliable, consistent end user experience. And this is something which is very close to our mission and something which we want to solve. Any questions? Otherwise, if you can ask now, but here are our emails, my Tivana and Bob Semmer. Please feel free to reach us if you have any specific questions. We can certainly answer questions now.
Just on this best practice guide, setting permissions for owner and non-owner for calendar sharing. What does it mean exactly?
So this is where people do a lot of calendar sharing. I'm sharing with you, or this scenario is not very applicable to admin scenario where they have like exact calendar sharing and all. But for permission for a non-owner to an owner's calendar, so that if you see there is a permission model when you are doing that. So I can show you after this thing if you are interested how to set it up on your Outlook.
Because everybody has FreeBusy by default.
But sharing is not very common scenario, but where people share calendars, I can show you right now after this talk like how they do it. Any other question? Sure.
Thank you guys. How are considered APIs here, or how is like Mailskate and some of the other vendors now trying to, they're saying that they can build reports and performance reports to give you kind of eyes into the online experience as well as our hybrid experience. And the second question for you guys is something I would imagine you thought about is maybe it's version 2 is how can you expand upon this to more of a hybrid platform, right? Because we got a couple single point of failures that we're going to host that are pretty significant on the online service, and the challenge that I see is that we just don't have the resources and bandwidth to run SCCM or whatever the tool may be, and we're not really getting the best KPIs or reports, but ultimately we need to give the same experience of both a on-prem hybrid as well as what we're using in the cloud. So I'd love to see, I can tell you from a large enterprise pharma company, I would love to see, you know, you guys expand that service out, and that we would be able to, you know, look at adding those agents or something on our systems to get a better holistic view.
No, absolutely. It means I'll answer both your questions. The first one was like how to rationalize with what third parties and all are doing. I think third parties in a way are doing help to us because they are measuring and monitoring, and you guys get an inputs into that. But the core difference here is the client, the inner mechanics of client, what happens on server. Those are kind of things which are very hard to comprehend if you don't have the stack end to end. So means you can run a tool which can say you the number is 7 second or 8 second, but dissecting that 7 and 8 second and putting it into pieces like where every 100 millisecond is being spent, that is something which third parties usually have challenges. They can cover one part, like they can cover like network probably better, like how is routing and all those things happening. But of course they don't have visibility into what happens when you come to our service, right? So that's one part. I think there is a need for that because we haven't opened these things very well so far, so that's fine. Yeah, that's your second question, like what do we do? Absolutely. So we have plans. I don't have the committed dates or something for this thing, but internally we have been looking into plans on how to enable these things to tenant admins and eventually to users themselves. So we, as a tenant admin, you will be able to go and see your entire population, the map which I was showing you. You can go and see the map for your user population and see like how your users in Japan versus China versus any other place are experiencing. And same thing, what ISPs does your users use? What kind of bandwidths and networks are there? All those things we have thought through. It's just like next one battle at a time. So the next battle is basically we will be exposing this thing. I don't have the timeline yet, but it's on the way.
Also, I mean, from the user's perspective is important, but it's also from the server infrastructure. So I'd love to see, you know, so I can guarantee you my CEO is not going to the cloud anytime soon. It's just not going to happen. So I'm still going to have ADFS, I'm going to have all the other hybrid tools that I'm going to need to run, and I'd like to see that as part of your bigger picture and kind of help monitoring that same space.
I think there are two parts to that thing. I think, as I said, we have plans to open few of these data points to our customers. It will be great if we can start getting these feedbacks from folks like you, like what more do you want to see from that? So if you can send me an email offline, I can share what are our things which are in pipe, and of course we would like to hear from all of you what more do you want which can make your life easier and give you more transparency. We want to be very transparent in this thing so that people know how the experience is and what is the problem.
So the last bullet point there about WAN accelerators, it worries me a little bit. So our current environment, we have Exchange 2010 centrally and a bunch of international sites, but the way that that's working in a good performance from my perspective is because of WAN accelerators. We're using riverbeds. And I mean, are you really suggesting that it's a bad idea to do that, or what are the known issues with trying to use that in Office 365?
So here's the deal. Our guidance on this is neutral. Use it at your own risk. We are neither discouraging you nor encouraging you. The problem is we don't use these WAN accelerators in any of our environments, so we don't know what gains you are getting. If you are getting a gain, I wouldn't say that. I will just recommend you to not use it. But the thing is, troubleshooting becomes very complicated when you have these kind of devices sitting in between your endpoints and our network. In that case, the only request we are making is you should have an ability for us to troubleshoot by bypassing these WAN accelerators so that we can know what exactly is happening.
So how is the Office 365 traffic routed? So all the mailboxes are going to be in the U.S., but we're going to have international users from most countries accessing the mailbox. How is that routed?
Yeah, so that's the power which comes with Exchange 2013. If you see, our roles are very loosely coupled, right? Like our client access servers are not married with our mailbox servers. So today we do it in a combination of BGP and Anycast. Our goal is to go more and more into Anycast so that your point of entry into our network is closest to you.
It'll be in country.
Yes, it is already for many locations. It already is. And our goal is that we want to, within less than 50, 30 milliseconds, we want you to be able to get to our network. And once you are in our network, we can control how, we can give you an optimal experience because of predictable routing. I think we are a little over time. I'm available here if you're.